So while we're on the topic of doors, let's go ahead and make a third type. Let's make one that's physics-based rather than animation-based. One where you can grab and open with the movement of the mouse, similar to the classic horror game Amnesia. So if we go into Blueprints, our Blueprints folder, Actors, this will not actually use the BPI interaction. Speaking of all of this, we can close it all. It's getting kind of cluttered. I'm going to leave L1 character open. This will not use the interaction interface. We're actually going to be creating a second one for that, for our left mouse click, since we'll be using a separate button. So let's right click and let's create a new folder, and we'll call this grabbable. So we have our interaction actors, we have our grabbable actors. We'll be adding more other than just the door in the future, which is why I'm making a folder for it. So let's create a blueprint class of type actor, and we will call this BP physics door. And like always, we have to add our static mesh, and we can call this door frame, and it'll be our door frame. And once again, add a second static mesh. Oops, there we go. Call this one door, making a child of door frame. Make the mesh SM door, and move it 45 units on the y-axis to center it. So let's compile and save. So we need to enable physics on our door. Not our door frame, this will not be physics based, but we do want to enable it for our door. So if we scroll down, we have this physics tab, and we can check simulate physics. There's a couple parameters we need to change. One is the mass. It automatically calculates the mass. As you can see, it's 29.22, but we want to enter it manually because I don't believe 29 is enough. So if we just check this, we can change it manually. I'm going to make it something like 150. We also want to bump up the angular damping, which will kind of smooth out and slow down its angular movement, because it definitely, at its default of 0, it definitely feels like it swings way too easily. So we want to up this to something like 4. We don't have to worry about linear damping because it doesn't actually move in a direction like that. It only rotates. And to make sure that it only rotates on the z-axis, nothing else, we can open this constraints tab, and we can lock the positioning for x, y, and z, and the rotation for x and y. So now the only thing it can do is rotate on the z-axis. This is great, but we don't want it to be able to rotate farther than 90 degrees. We don't want to be able to hold in, start doing this with our door. Set that back to 0. So to do this, we add what's called a physics constraint. So let's search for physics, and right here we have physics constraint. It doesn't need to be a child of our door frame. Yeah, it can be on its own. So here in our physics constraint, under the linear limits, they're all set to locked. That's fine. We can close that. In angular limits, we only want the swing 1 motion. So let's change our swing 2 motion, our twist motion, to locked. Our swing 1 motion will be set to limited, and the limit we want is 90 degrees. If we look, this actually changed the little icon down there for our physics constraint. If we change this again, you can see it updates with it. So change that back to 90, and that's what we want. So we need to let the physics constraint know which items, which meshes to affect. So if we go up here, under constraint, we have these component names. So for component name 1, we want to take our door frame name. So we'll type in door frame. And you can see it's highlighted our door frame. You need to spell it the exact same way it's spelled up here, which is why we named them manually. And you'll know you do it right. You've done it right if it highlights it. So for component name 2, we're just going to use door. And it's highlighted this one in blue. We also here want to choose disable collision, because we don't want these two to collide with each other, because that can create some physics problems. They'll still collide with everything else, but they will not collide with each other. Let's turn down our projection angular tolerance to 90, and we want to move our actual physics constrained position to the correct location, which is Y45. Now for me, when I created it, I accidentally created it as a child of the door, so it automatically moved it to Y45, but if you didn't, it would still be in the center. You want to keep it on Y45, where the pivot is of the door. We can actually test if this is working now, just by dragging our door into the world and walking into it. So if we walk in, we can see it's opened up physics-based, and it stops at 90 degrees. It doesn't go farther than that. And it's the same on the other way. Great. So for grabbing this, we're actually going to be using a different interface called BPI Grab. So if we go to Blueprints, Init Interfaces, we want to create another one. So Blueprints, Blueprint Interface, BPI Grab. Open it up, and we're going to rename this function Grab Object. We will also need a second function for this, so we can click Add New Function. This will be called Release Object. And we can compile and save. So we want to use our left mouse click for grab. To do that, we'll have to add another input. So let's do Edit, Project Settings, go down to Input, and we want to add our action mapping. And I'm going to just call it LMB for left mouse button. Type in left mouse button, and we can close that. So in our L1 character, we can create input LMB, and when we press it, we can create a line trace. And that's why we made it a function, so we wouldn't have to just keep copying over all this code. I'm going to keep the length at 350, since it's also like a reach, and we can change the debug type to for duration, just to test that pressing the left mouse button now also creates a line. So this is me clicking the left mouse button instead of E. Okay, so back in here, and we can change this debug type back to none, and we're essentially going to do the same thing right here, where we want to copy and paste this. Basically, we want to ask if the hit actor is valid again, and if it implements the interface BPI grab. If so, we want to call the function grab object under BPI grab object message. That's what we want. Plug that into true. Compile and save. Before we continue, we want to actually promote this to a variable, this hit actor right here. Promote to variable, and we will call this grabbed object. Now we can click on it, and we actually want the variable type to be object instead of actor. So just search for object, scroll down, and choose it right here. It'll give us a warning because it's plugged into something. Just press change variable type. We shouldn't get any errors. Compile and save. So let's add this to this right here. And just to keep things clean, we can plug that in there and break the link to the line trace. Compile and save. So now let's actually add this interface to our BP Physics store. So let's open it up. Click on Class Settings and Implemented Interfaces. We want to add BPI Grab. Now over here, under Interfaces, we've now created these two functions, Grab Object and Release Object. So under Grab Object, right-click and choose Implement Function. And we can call a print string to test, like always. And we can say hit a grabbable object with our left mouse button. Compile and save. So we press play, we click on anything, nothing happens, but if we click on our physics store over here, hit a grabbable object with our left mouse button. Great, so let's go back into our physics store, and we can just delete this string. And what we want to do when we first grab the object is we want to disable our ability to walk around or move the camera. Because if we grab the door and we move the mouse to open the door, we don't want our camera moving with it, because that'll become very annoying and very hard to use. We also don't want to be able to walk around while this is happening, so that you can't walk very far away from the door but be able to continue to open it. So, right click, get player character, and then we want to get movement, get character movement down at the bottom there, and we want to disable the movement. Plug that in. Next we want to get player controller, and we want to set ignore look input, and we want to set that to true so we ignore our input. So we can test this out. If we go into our level, we press play. I'm clicking on doors, the non-physics doors, nothing's happening. But when we click on this physics door, I can no longer move around, and I can no longer look around. I'm pressing the WASD keys, and I'm moving the mouse, and nothing's happening. So next we want to enable the input directly in our physics store. Let me just delete these three while we're here. So off of get player controller, we want to enable input. Plug that in. Now the target is this, not the player controller itself. So if you remember, if you hold down control and click this, we can move this to player controller, and self becomes the new target. So now, after grab object is called, we can now have the ability to call inputs from this actor. So if you right click and we input look right, if you remember, this is the axis input we made in the beginning, which is our mouse X, moving our mouse left and right. From this input, we will call a custom event. So right click and add custom event, and we'll call it move door. Let's add an input to it, and we'll call it this just amount, and we'll make it a float. And from this amount, we want to make a rotator. Instead of X, we want this on the Z, because we want the door to rotate on its Z axis. So let's drag in our door, and we want to set the relative rotation, and we want to set the rotation to the current rotation plus this amount. So off of door, we'll get relative rotation, and we can call combine rotators. This will be the A and B, and the return value will be the new rotation. Compile and save. Now we just want to call move door from our input axis look right, and our axis value will go into our amount. We'll compile and save. Now we just need to be able to release the door once we start being able to move it. But we can test it out before we implement that. So once again, everything's fine. I can click on these doors, nothing happens. I can walk around. Now when I click on this door, I can no longer walk around. But when I try to move my mouse, moving it right and left will move the door right and left, instead of moving my camera. But there's no way to get out of it currently, so that's what we need to add now. So in our L1 character, right here for L and B, when we release our mouse, we want to call the release object. So we have to get our grabbed object. First, let's ask if it's valid. Make sure we actually do have a grabbed object. And if it is, we want to call release object message. Plug that into the is valid. By the way, there is 2 is valid nodes. So if we drag off again, type in is valid. They do essentially the same thing. The one I clicked on was this little question mark. This is just converts it to a macro. Because if we get this one, it's just a Boolean. and then you could call an if statement, and this would be the true and false. So is valid, is valid, is not valid, is not valid. They do the exact same thing, so either one is fine. After we set call our release object, we want to set our grab object to null. So we don't want to set it to anything. So let's go back into the physics store and implement the function for release object. And basically we just want to counteract everything we set for grab object. So we want to re-enable the movement, and we want to re-enable the look input, and then we want to disable the input from this actor. So if we get player, let's go with character first. There's no node for just enable movement again. You can see there's nothing there. What we have to do is set the movement mode from our character movement. Because if there were just to re-enable the movement, it wouldn't know which mode to put it on. The mode we want is walking. This is just our default mode. It's the one we've been using, and we don't need to use any of the others. After that, we'll get our player controller, and we will reset ignore look input. So it'll reset it to allowing us to look around. Then we want to disable input. Once again, we don't want this in the target, we want this in the player controller. The target is self. Compile and save. So let's test it out one more time. We can control it and we cannot move around or look around. And we release, and we are back to our normal state. And it feels very nice. There's one small issue. It feels kind of awkward, in my opinion, being on the other side of the door. I feel like when I move my mouse to the right, it should open outwards instead of come inwards. It feels fine on this side, but I feel like it should be inverted on the other side. This is, of course, personal preference, but I'll show you how to do it in case you agree. So to do this, we're going to be using the same logic that we use in our outward store right here to get our dot product. So we can just copy and paste this right here. So I'm going to copy, and let's go into our physics store, and we need to paste it for our move door custom event. So I'm just going to move this released object down a little bit, and I'm going to hit paste and bring this over. Basically, we need to know whether to multiply this amount. So we can get a multiply. Say float times float. Plug this into Z. We need to know whether to multiply this by 1 or -1 to invert it. So we can get a select node off of that. And the wildcard here, similar to the outward door, is just checking if this is greater than or equal to 0. I will plug that into index. If I can grab it. There we go. If this is true, we want to multiply it by 1, which is basically making absolutely no difference. And if it's false, multiplying it by -1, which inverts it. You can compile and save, and we have an error. And that's because we don't have a player ref. For this, we can just delete it, and instead get our player character, and plug that into get actor location. Compile and save. So let's test it out now. If I hit play, I can open. I pull to the right, and it opens the door. Pulling to the left, it opens the door towards me. Go to the other side, and pulling to the right opens the door again. I feel like that feels a lot better. Now, if you want to open the door slower or faster, basically want to adjust the sensitivity, we have to add a multiply node here in physics store in this look right. Pull this off, get a float times float, and we can just adjust this number. So if we want it a lot slower, let's do something drastic like 0.1, so it's only 10% of what it would be. Press play. Try to pull it around the same amount I have been. It only opens about that much. basically pulling this across my entire mouse pad right now. If you want it to be more sensitive, you know, you would do it like something above 1, like 2, which I definitely wouldn't advise because 1 itself is already pretty sensitive. I'm going to change this to maybe 0.6. We can see how that feels. And I think that feels pretty good.